Hello and welcome to the first video in the B series. So, as whenever we talk about physics, we must always start somewhere, and that somewhere will be the beginning. And the beginning in this case will be vectors. So now, what exactly is a vector? Well, a vector is simply a magnitude with a direction. So an example of something with just a magnitude would be speed. I'm going 60 miles per hour on the highway, or I ran 15 meters per second down the block, or something like that. So in each case, I pretty much gave you a magnitude, how fast I'm going, but I didn't necessarily specify which direction I'm going in. So for instance, I could have been going 60 miles per hour down south or east, or I could have been going 15 meters per second northward on nordoff. So that's a major difference between vectors and scalars. So a vector has, therefore a vector has two properties. It has a magnitude, like I said, and direction. So pretty much the magnitude of a vector will be represented by the size of it. So a vector with a small magnitude will be smaller, whereas a vector with a larger length or whatever will represent a larger magnitude. And a direction simply upward or downward, any direction pretty much. And also, in addition, when we talk about vectors, let's say I have a vector, this is vector A like that. The magnitude of vector A is going to be signified by this. It looks like an absolute value, but this represents the magnitude of it. And then the direction, we usually denote it by either an angle above the horizontal or using unit vector notation, which don't worry about it for now. We most likely will not need it for the B exam. We won't need to know about it. However, we will need to know about how to add and subtract vectors. So, first off, let's start off with adding vectors and finding which direction they point in. So, for instance, let's say we go east about 5 meters, and then at some point we also decide to go north 10 meters. What's the resultant vector? Or in other words, how far away am I from my initial position? Well, when you're adding vectors, what you do is, first, you're going to copy one of these vectors. So for instance, I want to copy this 5 meter vector. And sorry if it's not drawn to scale. 5 meters is clearly smaller than 10, but anyways, we start off by copying that. Next, we're going to look at our next vector, which is, in this case, this upward 10 meter one. We're going to put the butt of it onto the head, and then just copy that same vector over. Now I'm going to check and make sure that I don't have any other vectors to add, and since I don't, I'm going to mark this as a final position and this as the initial position, and then draw a vector from initial to final. Now this here is my resultant vector, and pretty much if I want to find the magnitude of my vector, I'm pretty much going to use the Pythagorean theorem. If you notice, this is a right triangle, and if this is 5 and this is 10, then this is going to be 5 squared plus 100 squared, and then the square root of that, or the square root of 125, which is equal to 5 rad 5. So that's one way to add vectors. And I will now do a more complicated example. For instance, let's say we have vector A, vector B this way, vector C in this direction, and then we have vector D down this way. So again, I'm going to use the same head to butt rule. First, I'm going to copy a vector. So for instance, I'll copy vector A. Vector A. Next, I'm going to take another vector. I like D, so let's copy vector D. So what I'm going to do is take the butt of D and put it on top of the head of A, and then I'm going to draw it down this way. Copy exactly how it looks. And then I like C, so I'm gonna draw C next. So let's going to go horizontally in this direction, and this is C. Now, the last one, vector B, I'm going to copy the vector, put the butt onto the head, and it's going to be something like this, somewhere around here. So now I'm looking here and I've used up all my vectors. So therefore, now I'm going to draw from my initial position to my final position. And here is my resultant vector. So pretty much when finding the directions, you do this type of rule. You pretty much do the head to tail rule. And then once you're finished, you draw a point at your final position, a point at your initial position, and then draw a vector from initial to final. Now, one last thing, how to subtract vectors, and this is all in terms of direction. So let's use a very basic example. We have 4 meters, or I shouldn't use the words yet. Say we have vector A in this direction, and we have vector B also in the same direction. Now, if we add vector A and B, we know that we'll just do vector A, and then plus vector B, which will be copying the same vector but putting it on top of the head, and then that will turn into a vector R, which is equal to A plus B. Right? However, what if we want to subtract those two vectors? Well, subtracting is pretty much adding the vector in the opposite direction. So, in other words, if I want to do A minus B, what I'm going to do is redraw my picture, vector A, but instead of drawing B in the same direction, I'm going to draw it in the opposite direction. Now this is pretty much A plus B, and we can do that. We're going to draw A, and now we draw B, so we take the tail of B, put on top of the head, move it to the left, and we draw the final position, and we see that we have a net vector to the right. Smaller than A, so we see that like the vector shrunk. So these are ways of adding and subtracting vectors for the direction, to find the direction they point in.